Greetings, it's Jerry here. Today we're going to try and repair this glorious example of 1970s cassette tape technology. I bought this as part of a bulk buy of cassette tapes and units. I'll put a link to a video where I actually show you what I bought, just as an example of what you can get for, I think it was $35. The thing about cassette tapes is every single one of them is going to need to have at least the belt repaired on them. And because of that, they're not worth much money. Now, obviously there are iconic designs which are worth more money, but things like this, virtually worthless if they're not fully functional. Today, I'm going to get this up and running, and I'm going to show you how easy it is to do. We're not going to get this back to the level it was when it came directly out of the factory, but we'll at least get it working and hopefully save it from being chucked in an e-waste pile. Because there are plenty of people that wouldn't mind having something like this sitting on the shelf and putting a tape in and playing it to show their friends or something like that every now and again. And I think it's a really worthwhile project to do stuff like this. And while prices are really cheap for stuff like this, why wouldn't you give it a go if you have any sort of interest in it at all? As I always like to say, if it's broken, what have you got to lose? So join me as I go through how to repair this. If you like stuff like this, please think about subscribing to my channel, but let's get straight into it. This is the model JVC 9407WH. I like the look of this thing. I would say it's 70s. I will look it up. For the moment, I just want to see what is wrong with this. So I'm going to plug in the AC and see if it turns on. Whoop. Okay. So it's just got a bit of a dodgy power connection there. It's probably a bit oxidized. I might have to mute out any music and stuff like that so I don't get a copyright strike. I was going to turn the radio off, but the off button doesn't work. Is that right? Okay, so I'll just have to turn the volume down. So the radio definitely works. It's all a bit crusty on top. I'm going to have to give that a bit of a clean. I really love the look about this. It's got a lovely green display here. I don't know whether that lights up. It doesn't look as though it does. Maybe it doesn't. So we've got the VU meter, tape counter, all pretty standard stuff. This is interesting. So it's got a sleep on battery, and it's got mixing and pause. So I don't know what this is. I had a quick look online for the manual, but I couldn't find it. What I'm thinking is sleep off VU. So that's indicating the amount of battery life left in it. And when you switch it to sleep on, perhaps it stays on for a certain period of time, half an hour or something, to let you go to sleep before it turns itself off. Makes me wonder, does that only work for the radio? Because what would it do if it was a cassette? Would it just stop the motor? I think that would be bad for the cassette. But I can't imagine it's sophisticated enough to actually, press stop and disengage the playhead. So that might be something that we can take a look at. So I just wanted to check out the tape, but we're not even getting the radio turning on. So this switch here is definitely dodgy in some respects. So we know that the switch here between the radio and the tape isn't working. I can't even turn the radio off. So I'm guessing we can't even test the tape at all, but we will just put a tape in here, see what happens. Press play. Oh yeah, it is turning. I don't know if you can see that. It is turning here. If I put the tape in. All right, now it's turning. But I'm guessing we won't get any output because we can't switch it to tape. It's just not doing anything. Okay, so I think I might give this a bit of a clean up. Just see whether or not get some of this dust off. I think it's been standing upright, and so all the dust is settled on top. I guess this has been sitting around for some time. Yeah, I think this is going to clean up very nicely. That's something I will do a little bit later. Give it a really good polish. But I think we'd better start pulling this apart and see if we can't get it to work. Okay, so I think that this unit actually came from a nursing home. It had somebody's name on it, the address, female, it's got a date of birth, 07, 80 years old at the time that was written. So this has been around for a while. And let's see if we can't get it back in action. So looking inside here, the battery bay looks quite nice. It's not rusted or anything, although there's a piece of plastic that's broken off. And I don't know if you can see this, but it looks as though somebody's repaired this spring using, well, it's all melted here, so maybe using a soldering iron to, maybe it broke off and they melted the plastic to keep that in place. That's okay, we're not going to be using batteries in this, because this will be taking D cells, is it? Which are massively expensive these days. Couldn't even afford it. So it looks as though there are some screws to take out here. Well, that was easy. Looks like we can just unplug this. It's handy. And what else is left? We've got, how's that? Made to repair. Whoops. Okay. Well, that was a mistake. So I've just dropped some screws inside. Okay, 4 screws. That's good. We got some dead bugs. Not great. Another little piece of plastic. It makes me wish that I had some canned air so that I could take a look. Ooh, look at all this crusty 1970s electronics. Ew. So what do we got here? So we've got our transformer converting AC into DC. Got a speaker here. This is our amplifier and tuner over here. Got our pots. Here we might put some contact cleaner in all of the switches and things like that when we get to it. I didn't really show you the mechanism. So the mechanism looks good. The buttons are really tactile. They look in good condition. We'll get into that in a minute. But there's so much dodgy soldering going on, which is par for the course for something that's this old. But it looks as though down in here is the plate where the switches are. So this is what we're going to have to look at to try and figure out what's going on with the switch that turns the radio on and off, which isn't working. And also we're going to have to pull this out and we'll be able to get to the belt and the motor and all that sort of stuff underneath there. So it's just a matter of undoing some screws and trying to figure this out. So that's definitely one that's holding on the PCB. Looks like this is another. What else have we got going on here? Feels like there is more. Just got to go gently because these PCBs can be very delicate. Okay, so there's another screw under here. And that also goes for the wires. The solder joints that hold the wires on. So really just want to be careful when taking it apart. Pull anything where it doesn't want to go. So it feels like there's one more screw somewhere. So it's loose there. And there, oh yeah, there's a hidden screw underneath there. Feels like it's been held on by just the wires. So we've got some sort of wire clip here. Okay, so all of those wires go under there. Okay, so can we bend that back? Well, that's pretty good. We can get at the mechanism, the belt, very easily. Unfortunately, we're not going to be able to get at the circuit board for the switch as easily. And I'm wondering whether I should just put a bit of contact cleaner down into the switch from... No, I think we need to pull it apart. I mean, we could just try spraying contact cleaner into the switch. That does actually work sometimes, but I really want to take a good look at it. If we want to adjust the speed of the motor, we have to remove the motor. So I think we just need to free up some of these wires, give us a bit more slack to turn this PCB over. One of the problems is if you change the belt, you often want to recalibrate the speed of the motor to make it work properly. But in order to do that, unless this has actually a mechanism for doing it, a way of getting to the back of the motor, and normally they don't in these sort of units, you actually have to pull everything apart and have everything hanging out and adjust the speed of the motor while it's all sort of half put together. There's no point putting it back together, you know, and then trying to... Oh, okay, so I've just noticed something here. We have broken plastic. So this plastic here, is that the switch? Ah, so in this is probably the switch here, this, and this is completely broken, and that is the switch that turns it from the radio to the tape. Ah, and that has been broken, so it will not switch, and it's been very significantly broken. So that's going to be a problem. I mean, it all looks to be there. We can try super gluing it back together, but that's our problem with the switch. Yeah, so it's a mechanical failure. It's not the switch itself. All right, no problem. And just looking at this switch, it's really quite stiff. Maybe stiffer than it should be. Maybe that's caused it. It became so stiff that it needed to. The pressure was too much. Now I've got some contact cleaner here. What is contact cleaner? It's very similar to isopropyl alcohol. Maybe it's the same stuff. And the reason that we use isopropyl alcohol to clean things in circuit boards and things like that is it basically evaporates almost instantaneously. So it doesn't leave, it doesn't stay there long enough in order to cause oxidation or rust or anything like that, because some metal parts will start rusting within minutes. Similarly, contact cleaner, rapid drying, and it also contains something else that attacks the oxidization. And so when you put it into switches, you need to actually activate them. You need to physically move them in order for it to work, but it will hopefully clean off the contacts and get the oxidization that's on there off. If you don't have this, you can just try using isopropyl, but we might just put this in here, and then we need to give it a good it's a really strong click. So this isn't really a lubricant, so and I wouldn't put lubricant in a switch like that. It may just always have been a really positive mechanism. So there's other switches in here. So here is a switch there. And it doesn't hurt to do this, and to put it also into the pots, the variable resistors, the potentiometers, whatever you want to call them. So they're here. If they're all scratchy or something like, you turn them and they're sort of scratchy and stuff like that, you can just spray a bit into them and give them a bit of a turn. I don't think it needs it, but since I have it in my hand. Okay, so the first thing that we need to do is, we don't need to get at this circuit board where the switch is, because we know what the problem is. We might be able to try gluing this back on together. Now, we do need to remove this mechanical part in order to get at the back of the motor if we want to adjust the speed of the motor. With a unit like this, calibrating the motor, may not make a huge difference to it. It's not a high-end unit, stuff like that. You probably won't notice any difference. But if we change the belt and it is way out, then we can change the speed in which the motor turns. But usually and I don't know why this is, but you have to get at the back side of the motor and adjust a screw or a potentiometer that's in the back of it. That's really difficult to get at. So I guess we'll have to undo some more screws before we can get that out. And we also have to figure out how to get this belt out. Oh, this belt is, oh, it's very crusty. Oh, it's almost broken there. If I just give it a bit of a tug, that would snap off. But I do need to figure out how to get it out without breaking it, because I need to put one back in. Now it looks to me as though there is that a screw? Is that a screw that has been Loctited down? And we need to, my worry is it looks as though it's made of plastic, but it can't be. I think that's just Loctite to stop it coming undone. Yeah. So I think if we pull that out, we can pull, no, it is. It absolutely is made of plastic. Well, that's interesting. Will that allow this wheel to come out? Well, it'll definitely allow it to lift up. And will that allow us to pull the belt out? This is where the service manual would be interesting and helpful, but yes, okay. Excellent. So there's our belt. And it is, yeah, very brittle and it's almost broken. We need to get some more belts. So here's my collection of belts. So these come from off AliExpress, eBay. You buy them for not much money. You get like 60 belts for $3 or something like that. And they're not great quality. And the thing about cassette tapes is that because it's an analog mechanism, anything that interrupts the smooth mechanism so that the tape doesn't move at a constant speed is going to cause problems with the playback. And it's been well documented that these aren't the best belts that you can buy. But the thing is, unless you are going to spend $10 on a belt and you're sure that you know the size of the belt and all that sort of stuff, is it really worth it? In most cases, what I've seen is this is good enough for something like this. If you just want to get it back working, and then if you want to do it properly and you want to get it 100%, then yes, once you get it working, you can go, okay, well, let's go and find the proper belt for this. But I don't see the point in that at this stage because we need to get it working first. Once we get it working, we can decide how bad it is. In actual fact, I'm going to attempt to calibrate it. I'm going to show you how that is done. And from that, we can tell whether or not we're happy enough with the belt that we eventually put on, if we can find one to suit, because yeah, that's quite a long belt. And I'm not sure whether, you know, this grab bag of belts is going to contain anything close to the right size. It looks to be the longest one, and it's nowhere near thick enough. This one is probably stretched, so it might be okay as far as putting it on. If it's too tight, we can adjust the speed of the motor and to accommodate that, but it is nowhere near as thick as the belt that was on there. Okay, well, let's just put it on and see how we go. That's the first thing. I'm going to put it underneath there. That was easy. Honestly, I think that was the easiest that I've ever put a belt on. Yeah, and so then we've got this plastic screw which holds this down. I need to be very careful that I don't cross thread the screw on this one. That would be very easy to do. I wonder if the only purpose of that is just to hold that big pulley down, or whether it's also used to adjust the tension on the belt a little bit, because there's this hole in the circuit board that allows you to adjust it. Yeah, see, now that's not turning very well. I don't know. That would be a much better way of adjusting the speed. I should have counted how many times that I unscrewed that. That's sort of a rule that I normally have when I... Yeah, so that can't move, but it's definitely freer than it was before. So maybe that is the adjustment. Instead of, you know, instead of adjusting the motor speed, this will actually affect the speed that it can rotate. Who knows? We could almost turn this on if we can make the switch work. Maybe just temporarily. Well, actually, we can just flip the switch manually and then put some power onto this thing and see if we can't get it to operate. And just see what the tape does. Radio off is down, which I think would push this switch up. So we've pushed that switch up. Now the thing is, I don't really want to power this via AC because I don't want to electrocute myself. I definitely want to use DC. So I can put my power supply onto this and give it 6 volts DC, and that will be a lot safer if I've got the back off. Okay, so I've got my power supply hooked up, which I hope is around the right way, or else we're going to see some sparks. And I've just screwed this board back in with one screw. So, fingers crossed. Let's turn the power on. Let's see how we go. So, do we have radio? No. So if I flip, where's that switch? Okay. So that works. So I've manually activated the switch, which has the broken plastic. So now it is radio off. Let's put the tape back in. Can't remember which way tapes go in, whether that's the beginning or the end. And if we press play, haha, it's working. So I don't know if you can hear that. Actually, I might put the microphone close to it. But what you'll hear is it's all sort of warbly. So there's a couple of things that cause that. So that's the wow and the flutter. So wow, I think, is it going fast, and flutter is when it goes slow or something like that. But basically, it's an analog system. So as the motor turns, it has to turn in a very specific speed, and it mustn't slow down or speed up. Everything needs to be lubricated and properly functioning, or else it gets this problem. So if you just listen to this, I don't know whether I'm going to have to mute it because of copyright or not. It's Mozart, so I'm not really sure. But I think you'll hear that it's terrible. So here we go. Okay, so it's working. Now we need to do a couple of things. We need to clean it first of all, in case it's just needs lubricating and cleaning. And then we also need to try and adjust the speed of the motor if that doesn't fix it, in order to speed it up or slow it down. So I'm seeing another belt in here that appears to... Oh, that must be the tape counter. Yes, it's going to the tape counter. Okay. We need to clean this, and so it would be good if we could remove this. Sometimes it's easy and sometimes it's not. But I think the safest thing is to actually remove the whole mechanism here, so that we can get at it, give it a good clean and lubrication and etc. So let's do that. So I'll take out this one screw that I put back in, and let's look to see how we can get this apart. So what have we got here? So it looks as though we've got some components down in here that are screwed to the metal. Maybe they're transistors, and that's for heat sink. But let's just remove that. You can see that. I think that they are transistors, old resistors, transistors. Okay, so that allows us to push that whole thing back. That's much better. Okay, so now the mechanics of it. I don't want to pull apart things that I don't need to. So we've got some more wires attached here. So what needs to come off? Man, there's just stuff everywhere. So I can't really see what's holding this down. Maybe there's a screw there, maybe that's part of it. But it also, these standoffs here seem to have a cut in them. I wonder if they, oh yes. That's part of the mechanism for holding it in. And I'm guessing that this here is also for holding it in. There's another one of these standoffs here, but I'm not sure whether that's attached to here, but we can try removing it just to see. If I unscrew that a bit. Oh yes, okay. Yeah, it sort of feels like it does want to come out. Don't want to force it. I definitely don't want to break any wires, disconnect any wires. Okay, it looks as though there's a flap under here that isn't connected, but you can't pull it out because it hits on that. So it's like it needs to move this way. I was going to say this seems actually quite easy to pull apart, but now that I've come to this, I'm wondering whether this board needs to come out as well before you can finally get it out, which is a pain. God, I was hoping I didn't have to disassemble every single thing in order to get it to come out. Worst thing you can possibly do with units like this is to manhandle them. Better to try everything to get things to come out gently. Definitely need to remove these. They would definitely be holding it in, if that's what... Nope. Feels like there's something else on this board. There's another screw down there, which I can't tell what it does. Just gonna loosen it. Yeah. It feels like there is something else over this side. Okay, another one of these standoffs. Moving. Oh, yeah. Might help if we remove this. There's a screw in there. Let's just remove it and see what happens. Is that doing anything? Oh yes. Feels like it's coming. Yeah, it was just a matter of levering it in the right spots. Ah, so there we go. That's what we've got here. So there's our tuner. Nice. So why was I getting that out again? Oh yeah, because I didn't think I could get this part out. Bingo. Oh, I hate this. I hate how you have to do this. Ah, it looks like there is a repair here maybe, or is that wearing? All right, well I'm glad I didn't try and remove this, because it doesn't look easily removable, if it is removable at all. I don't think it is. So this is the mechanism, and I can see the tape counter belt in here as well, so we might as well try and find a belt for that. Please don't say I broke that. Oh no, that is the broken one. Yeah, of course. It's the bit we need to fix. All right. So it definitely needs a good clean inside here, and we can also go and change this belt out. I believe that should be fairly simple, though I've said those things in the past. I mean, the tape counter was working anyway, so we can always put it back on. But since we're already in here, that's the belt itself. Actually, that feels pretty good. So that's the original belt. This is the one we're going to replace it with. Let's get in there and clean out the whole mechanism. Now, I don't know if this is going to work, but in a previous video, I got a $3 endoscope from AliExpress for the purpose of doing things like this, to see whether or not it was any good, to try and give you a bird's eye view of the inside of one of these. So I don't know how this footage is going to turn out, because I have to manually focus it, and I can't really see what I'm doing from this angle where my monitor is. But I'll just take some shots inside, so you can see that hopefully that it's pretty dirty and gunky in here. This here is the play record head, just there, which needs to be cleaned. And I think this is the erase head. You can see there's the pinch roller, there's a capstan roller there. All of these things need to be cleaned and perhaps lubricated. Not the have to be very careful with lubrication. So just the capstan, really, you don't want to get any oil or anything on the pinch roller. So this is the pinch roller here. It pushes up against the capstan, which is spinning, and that pinches the tape between it and allows it to travel, you know, past the playhead. Yeah, anyway, so it's dirty. and it needs a good clean out. But there's nothing to it really, it's just a matter of cleaning it with isopropyl alcohol. Okay, so I've got some cotton buds here, dipped in isopropyl alcohol. I'm not going to spray anything in here, you have to be very careful, because if you get lubricant and stuff like that actually on the pinch roller, and you know, in things that are supposed to actually spin, they can slip and then nothing works. It's really just a matter of getting in there, cleaning out the dust. I'd probably use an air duster if I had any, but it seems to have disappeared. So I just want to get all of the gunk out that I can, and then I will clean the pinch rollers and maybe lubricate the capstan roller itself, but very, very carefully so that no lubrication can get anywhere else except down into the cavity where the capstan roller is. Just the minutest amount of oil or something. I have to figure out what I've got. Alright, so I'll come back when I have done all of this. So I've cleaned the major parts. I'm just going to do the pinch roller now, and I'm just spinning it around and doing that. I don't know if you can see how that, but it's very black, and you don't want to transfer that stuff onto it, so just keep using a fresh one. Keep spinning it around, change ends, and you need to do this until it's completely clean. I did check the pinch roller to make sure that it was okay, like it wasn't, the rubber on it hadn't degraded at all. So it's just dirty. And what we're trying to do is we're trying to clean the path that the tape takes, so there's absolutely no dirt to catch the tape up at all, to slow this tape down. Tape needs to slide through cleanly and smoothly. Wow, I just can't seem to get this clean. It's really disgusting. The pinch roller is clean. It took about a dozen cotton buds to do it. And I'm just going to clean anything that's in the way of the tape. I'm going to rub it over the tape head here. Which seems fairly clean. And give the erase head a bit of a go as well. That's good. So I'm thinking maybe I will put a tiny amount of oil down here. The capstan roller, just in case that needs a little bit of lubrication. What can I use? I'm going to use some of this oil here, but I need to use the most tiniest bit that I can, and I need to drop it exactly down into where the shaft is. I've just spilt a drop. I'm just using, I don't even know what this is, but I've got a little bit of oil down in there, and there was a drop that just made its way down there. I'll get rid of that. The most important thing is that no oil gets onto the tape path. in particular the pinch roller. So I really need to clean up that, just make sure that there's nothing there. And it's just the tiniest drop of oil that's gone down into there. Okay. Otherwise the tape will definitely slip. Okay, so it's clean. Or as clean as I can get it for the moment. So I think that I'm going to put on this tape counter. So I believe that goes there. Okay, so that's all back in place. So this is interesting. I've just turned the motor over. Now in the other tape decks that I've seen, there is actually a hole in the back here that allows you to adjust the speed of the motor. And there isn't anything here at all. Don't think there's anything under there. So clearly that's not the way that this works. In the higher end machines, they often have a trim pot that you can adjust, which adjusts the speed. So I'll have to have a look for that. But if you remember earlier on, I pointed out that this screw here might be what's adjusting the tension, like putting more friction onto this flywheel, and maybe that's what's stopping or is adjusting the speed. That's a different mechanism maybe. So that's something I guess that we can try. So this is the problem with these tape decks, is that if it comes to adjusting the speed, you really have to have everything connected but all hanging out of the case in order to be able to adjust things. This unit doesn't appear to adjust the speed by accessing the back, so we can put everything back together pretty much, and either it's going to be the tension on this that causes it to adjust the speed of the motor, or there's going to be a trim pot somewhere else where hopefully we can access it. Okay, so here are the bits. So it goes together like this. So there's a little pin that goes through there, and as you turn it, it goes like that, and catches a physical switch in the teeth here. The switch I've tried to, it's very stiff. I've tried to make it better, but it's just a really solid switch. And I'll be honest with you, you know, I don't really see this is working. If I oh my God, great. Apart from super gluing myself, get something to get that off. Yeah, apart from super gluing myself together and destroying my mat, oh God. You know, I really don't see this as working because there's just going to be too much physical stress on such a small thing. I really don't see it working, but we should at least try. I'm already super gluing myself together. All right, I've super glued it. I'm not terribly hopeful. No. wouldn't have lasted. Let's try. No. Okay. Let me see if I can find some epoxy glue. See if that does a better job. Okay, some cheap epoxy adhesive. Honestly, don't think there's any chance of getting this to work, but it's always worth a shot. I'm just going to end up coating this in epoxy, aren't I? And then it's going to dry on it, and it'll be all malformed. I think I'm better off just cleaning it off. And it's the next day. I put a hole in this container so that I could stand this up while the epoxy glue set, and this is what we've ended up with. I'm not going to wrench it. I think we just put it back in and actually use it and see how we go, and then if it doesn't work, then I might have to come up with a different solution later on. But definitely super glue didn't work. I didn't expect it to. Epoxy glue is so much stronger, so we might as well give it a go. Okay, so this hole here actually has to fit onto this shaft here, and then the switch goes through to the other side, and then the switch is on the bottom of this PCB. So as it hinges like this, it actually just flicks the toggle switch across from one side to the other. So looks like we can get a screwdriver in there, but this is in the way. So this is I think it's the heat sink for those two transistors that we had to remove earlier. So hopefully we can just remove that and get in here. Get this onto there. Yep. So the switch will go through the bottom. Must go this way. Yep. All right. So this goes back in there. Okay, there we go. Okay, so can we get this thing back together? Just check the other switches are in the right spot. Okay. So this is the switch here that this has to manipulate. And I've put some lubricant in there, I mean some contact cleaner to hopefully make it a bit, it's not quite as stiff as it was. So hopefully we can get this to work. Alright, so we just need to screw everything back together. And yeah, it's a matter of remembering which screws go where. It's the hardest part. Have a guess how many leftover screws and things I'm going to have. So I think this goes here. Okay, so I think we've got that far enough together so that we can have a look at seeing whether this is the adjustment for the speed of the motor. And it sort of makes sense because there's a cutout here allowing you to access it. Let's go over to the other bench. I guess we can try this switch to see if the switch works. I'm a bit nervous about it, but oh, actually there's nowhere near as much pressure to make this operate as I thought. That seems fine. Cool, all right, so that looks like it's going to work. Okay, so this is the exciting part. So this is the bit where we figure out whether or not we're going to let out magic smoke, whether anything's going to work. So have I put a tape in this? Yes, I've got a tape. Okay, let's turn the power on and see what happens. Power on. 6 volts. So the first thing to do is to test whether or not we've fixed this switch. So currently it's on tape. Put it onto radio. Yes. Ah, of course I don't have a tuner. Lovely. So now we can switch it to tape. So the switch seems to be holding up. And let's press play on the tape. Okay, so that seems to be working. It's a little bit hissy. If I turn the tone down, so it's really difficult for me to say the wow and the flutter and whether or not the speed is any different. We need to use a reference tape really to do that, which I have and I will use. I'll just say now though that if you don't have a calibration tape or a reference tape, the best thing to do is to put in a tape that you actually know the song to very well, an album that you listen to a lot, and just adjust it to your own ear. Most of the time, that just works. Okay, so what I'm going to do is I'm going to put in this tape here, this Mozart tape. I don't really care whether this tape gets eaten or not, but what I want to do is I want to let the cassette tape sort of wear in now that I've done this. So I want it to run through, it's a couple of tapes just to get it bedded down after I've cleaned it all and I've lubricated it all. And then after that, we'll attempt to calibrate the motor. I still don't know exactly whether or not this screw in here is actually doing the calibration simply by putting more friction onto the belt, or whether there's some other mechanism going on. But let's just do this first, because there's no point in trying to calibrate it and get the wow and flutter down if, you know, it hasn't been running in 20 or 30 years. It needs a little bit of time to wear in. So I'll do that and then we'll come back. Okay, so it's time to test the wow and flutter factor of this. Now I've already adjusted this screw at the back that we talked about, where the flywheel is, and I've done that off camera because I wanted to use a tape. I didn't want to get copyright infringement, but I can definitely say that as you screw in this plastic screw, it changes the speed. It gradually gets slower, and then when you back it off, it gets faster. So I'm pretty sure that that is the mechanism for adjusting it. So what's going to happen is I have this calibration tape, which is going to have a 3150 Hertz tone on it. I'm going to play this on here, and then we're going to go over to my laptop, and I'm just going to connect out of the headphone jack out of this into the microphone of my laptop, and I'm going to use a program to check the wow and flutter factor and try and adjust the speed of the motor to get it as close as I can to 3150. As I've said before, these cheap belts are known to be not very good, and so I'm not expecting to get anything great on this. However, what the manufacturer said that this unit could do, and what a human here can hear the difference between, is subjective. Some people will definitely be able to hear wow and flutter at a very low percentage, and other people won't notice any difference. I'm not expecting great things from this. As long as it's acceptable, that's enough for me. Anyway, let's get on with that. So the first thing we need to do is we need to put in our calibration tape. And I'll just let you hear what it sounds like. If you can hear that. Yeah, so it's just a whistling sound, but it's at a very specific frequency, and it is on a calibrated tape. So now what we can do is we'll just plug this in, and we'll get the program going on my laptop. Now you won't be able to see this, but all I'm going to do is put my screwdriver in here, and I'm going to adjust that screw in trying to get it as close as I can to 3150 Hertz. Okay, so I've got everything set up. The tape is running on the cassette recorder. It's going into the laptop. We're running our program here, and you can see that we have a lot of fluctuation here. We haven't quite reached 3150, so I might adjust the screw to see if we can get a little bit closer, but it's jumping around so much it's too big. Okay, so we want to loosen off the screw to see if it goes faster. So we're getting 3000. I'm not sure we're going to get much better than that. I don't think it's going to get any better than that, I'll be honest. So it looks like it can only get to about 3070. Going to adjust it back in. Then we're going to adjust it back out till we get to Okay, so I think that is as good as we're going to get with this. It doesn't appear to be able to go any faster than that. And that probably has to do with the belt, I imagine. So the RMS peak, I believe it's called, is, over 1.4. And the percentage is 0.6, 0.7. I think what we should be getting for this is 0.3. So we're not getting anywhere near what we should be getting. And I believe that is due to the belt. That's what everyone says, that these cheap belts that you get in bulk from China, it's impossible to get a really solid consistent reading with WoW and Flutter. Obviously there are other factors. Anything that affects the path of the tape moving through the mechanism will affect that, but we have cleaned it, and we've done everything that we can. This is a very old unit. I mean, this unit is 50 years old or something like that. So we really have to give it a break. Now, there are plenty of people who look at that and say, I couldn't possibly listen to a cassette tape with that amount of WoW and Flutter. But a lot of people can. The fact is that the tapes themselves can be a bit stretched and things, but because they're old as well. The tape that I'm using for this calibration is obviously new, and it's come from a reputable shop that has produced it. So I know it's okay. But if you play old cassette tapes that you've just bought from an op shop or something like that, it may be that the tape is out as well. So there's a whole bunch of factors going on here, but that's as good as I can get this unit without going to a more expensive belt. And even then, I would need to know exactly the type of belt. Preferably I would like to find the manual, which I can't do, and that would specify the model and all that sort of stuff. I know for a fact that this belt is not as wide as the original belt that came off it, right? Apart from the fact that obviously we chose a shorter one so that we wouldn't have the slack in it. Physically, the belt is not the same width. So I think this is about as good as we can expect from this unit at this stage. Okay, so we've adjusted the calibration as best that we can. And I have to say, I've played some of these tapes here, and really it sounds okay. I know that there are people that would just be shaking their heads and going, I could possibly listen to that, but really it's not a problem for me. So I'm going to put the whole thing back together and give it a nice clean up, and we'll see how we're doing at that point. Let's get all the screws back in. And I wonder how many screws we'll have left over at the end. All right, we're almost there. Let's get these knobs back on. Done. So it's all back together. How many screws did I have left over? Well, none. In fact, there's one screw missing. I have no idea whether or not it was there in the beginning. I'll have to look back through the video when I edit it to see whether or not there was one missing. Otherwise, I've dropped it on the ground somewhere and I cannot find it. But here we go. Let's find the AC connector and see if this bad boy is fully fixed. Got some Christmas music. Cool. All right. So let us switch this to tape. And this thing is back together and it is working 100%. You can see even the tape counter is working. My only real concern is how long this switch is going to last. I have no idea how that glue is going to hang together. So I'll use it for a while and we'll see how that lasts. If it breaks again, then I've been researching about how people fix these sort of things, and I think I might try actually using plastic welding to try and weld the plastic back together if it breaks again. That seems to be quite a popular way to fix plastic items like this. But as you can see, this is now back together, it's working. And the great thing about this is I have saved this from being chucked out, because the way that it was before, it would have just ended up in the garbage. But now that it is fully working, I could sell it, I can give it to charity, I could give it away, you know, and it really wasn't that much effort. How does it sound with the cheap belt on it? It sounds fine, honestly. For a cassette tape unit that is this old, it's perfectly acceptable in my eyes. Not to everyone, or my ears, I guess. But yeah, I'm really happy with that. Alright, I guess we will leave the video there. If you like what I'm doing, please consider subscribing to my channel, giving me a thumbs up, leaving me a comment. And also, if you want to see more repairs of cassette tapes, let me know in the comments. I'll definitely do that. I have heaps of them lying around the place, and they're always a lot of fun, and I always learn something, which is, you know, what I love about repairing stuff. And remember, you know, if you're thinking about repairing something like this, it's already broken, right? You can't make it any worse than it is. It's going to end up as garbage, so you might as well have a go. Anyway, I'll catch you in the next video. Ciao.